FastMCP 2 employs OpenTelemetry's native instrumentation to automatically generate traces for tool operations, enabling observability without requiring explicit configuration. This implementation leverages the OpenTelemetry API's no-op behavior when no SDK is present, ensuring zero overhead in uninstrumented environments while allowing full control over trace collection and export when needed. The upcoming code demonstrates how FastMCP's tracing mechanism is tested using an in-memory span exporter, where a simple tool's execution generates a span with the expected name pattern. You'll see the test fixture setup that configures the OpenTelemetry SDK with an in-memory exporter, followed by the actual test that verifies span creation when calling a registered tool. Import pytest. From collections, ABC import generator. From OpenTelemetry import trace. From OpenTelemetry, SDK, trace import tracer provider. From OpenTelemetry, SDK, trace, export import simple span processor. From OpenTelemetry, SDK, trace, export, in-memory span exporter import in-memory span exporter. From FastMCP, import FastMCP. At pytest, fixture. Def trace exporter generator in-memory span exporter. None. Exporter equals in-memory span exporter. Provider equals tracer provider. Provider, add span processor simple span processor exporter. Original provider equals trace get tracer provider. Trace, set tracer provider provider. Yield exporter. Exporter clear. Trace, set tracer provider original provider. Async def test tool creates span trace exporter. In-memory span exporter none. MCP equals FastMCP test. At MCP, tool. Def hello SDR. Return world. Await MCP, call tool hello. Spans equals, trace exporter get finished spans. Assert any's name equals, tools call hello for S in spans. This test demonstrates FastMCP's native OpenTelemetry instrumentation by verifying that tool calls automatically generate traces. The pattern uses pytest with an in-memory span exporter to capture and inspect telemetry data without requiring external infrastructure. The test sets up a controlled tracing environment using the trace exporter fixture, which temporarily replaces the global tracer provider with one configured to export spans to memory. This isolation ensures tests don't interfere with each other or require external services. The actual test registers a simple tool using @MCP tool and verifies that calling it via call tool produces a span named tools call hello, confirming FastMCP's automatic instrumentation works as expected. This approach validates observability without production dependencies, making it suitable for CI/CD pipelines. The trade-off is that in-memory testing can't verify distributed tracing propagation, which would require actual network calls. The pattern is particularly useful for framework development, where you need to guarantee instrumentation behavior without assuming specific backend configurations. Let's break it down. Import pytest. Imports pytest for writing and running test cases. From collections, ABC import generator. Imports the abstract base class, generator, from collections. ABC, which provides the interface for generator functions and iterator types in Python. This enables type hints or runtime checks for objects that produce values lazily via iteration. From OpenTelemetry import trace. Imports the OpenTelemetry trace module for distributed tracing instrumentation. From OpenTelemetry, SDK, trace import tracer provider. Imports tracer provider from OpenTelemetry SDK's trace module. which is the entry point for creating and managing tracers in distributed tracing systems. From OpenTelemetry, SDK, trace, export-import simple span processor. Imports the simple span processor class from OpenTelemetry's trace export module, which provides basic span processing capabilities for handling telemetry data in tracing operations. From OpenTelemetry, SDK, trace, export, in-memory span exporter import in-memory span exporter. Imports the in-memory span exporter class from OpenTelemetry's SDK, which provides an in-memory span exporter for testing and debugging purposes. This allows capturing and inspecting telemetry spans without sending them to a remote backend. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, which is the main class for creating FastMCP servers. At pytest, fixture. Def trace exporter, generator in memory span exporter. None. Defines a pytest fixture named trace exporter that yields an in-memory span exporter instance for testing OpenTelemetry tracing functionality. The fixture uses Python's generator type hint to indicate it's a generator-based fixture that yields the exporter, with no setup or teardown parameters. This provides a clean, isolated exporter instance for each test that needs to capture and inspect trace spans in memory. Exporter equals in-memory span exporter. Creates an instance of in-memory span exporter and assigns it to the variable exporter. This exporter is used for OpenTelemetry tracing, storing span data in memory rather than sending it to a remote backend. Provider equals tracer provider. Creates a tracer provider instance for OpenTelemetry instrumentation. This provider will be used to generate and manage traces for distributed tracing in the application. Provider. Add span processor simple span processor exporter. Adds a simple span processor to the provider, configured with the specified exporter. This processor will handle span data and forward it to the exporter for further processing or output. Original provider equals trace get tracer provider. Retrieves the current OpenTelemetry tracer provider from the trace context and assigns it to the variable original provider. This captures the existing tracing configuration before any potential modifications. Trace set tracer provider. Sets the global tracer provider to the specified provider object for OpenTelemetry instrumentation. This configures the tracing system to use the given provider for all subsequent trace operations, enabling distributed tracing capabilities with the provided implementation. The call replaces any previously set tracer provider with this new instance. Yield exporter. Yields control back to the caller with the exporter object, allowing it to be used in a generator context. This enables the exporter to be processed or consumed by the calling code in a lazy or streaming fashion, rather than requiring immediate execution. The yield keyword indicates this is part of a generator function that produces values on demand. Exporter clear. Calls the clear method on the exporter object, removing all previously collected data or state from the exporter instance. This resets the exporter to an empty state, discarding any accumulated exports, metrics, traces, or other data that may have been added since its creation or last clear operation. The exact nature of what's cleared depends on the exporter's implementation, but the immediate observable effect is that the exporter's internal buffers or storage are emptied. Trace set tracer provider original provider. restores the original OpenTelemetry tracer provider, replacing any previously set provider with the one stored in original provider. This operation affects the global tracing configuration, ensuring subsequent traces use the original provider's implementation for span creation and export.
A sync-def test tool creates span trace exporter. In-memory span exporter, none.
Defines an asynchronous test function named testToolCreateSpan that takes a single parameter trace exporter of type in-memory span exporter and returns none. The function is designed to test whether a tool operation generates an OpenTelemetry span, with the exporter parameter allowing inspection of the recorded spans during testing.
MCP equals FastMCP test.
Creates a FastMCP server instance with the identifier test that will be visible in MCP protocol handshakes for client identification purposes. The string parameter serves solely as a server label and does not configure any operational behavior or mode.
At MCP, tool. Def hello SDR.
Decorates the hello function as a FastMCP tool, making it discoverable and callable via the MCP protocol. The decorator automatically registers the function with the server's default local provider, using the function name hello as the tool name and generating an input schema based on the function signature. The return type annotation, SDR, indicates this tool returns a string value.
Return world.
Returns the string literal world as the output value of the function.
Await MCP. Call tool hello.
Invokes the hello tool through the MCP client interface with an empty parameter object, executing the latest available version of the tool. The call is asynchronous and will wait for completion before continuing execution.
Spans equals trace exporter get finished spans.
Retrieves all completed tracing spans from the OpenTelemetry trace exporter. The getFinishedSpans method returns a collection of span objects representing completed trace operations, which can then be processed or exported for observability purposes. This is part of FastMCP's native OpenTelemetry instrumentation for distributed tracing.
Assert any's name equals. Tools call hello for S in spans.
Asserts that at least one span in the spans collection has a name attribute equal to the string tools call hello. The assertion passes if such a span exists, otherwise it raises an assertion error. This is a verification check typically used in testing to confirm that a specific tracing span was created during execution. This test showcases FastMCP's native OpenTelemetry instrumentation by verifying that tool calls automatically generate traces without explicit configuration. The pattern uses pytest with an in-memory span exporter to capture and inspect telemetry data in isolation, making it suitable for CI/CD pipelines. The fixture sets up a controlled tracing environment by temporarily replacing the global tracer provider, ensuring tests don't interfere with each other. The actual test registers a simple tool using @MCP tool and verifies that calling it produces a span with the expected name pattern, confirming FastMCP's automatic instrumentation works as designed. The trade-off here is that in-memory testing can't verify distributed tracing propagation, which would require actual network calls. This approach is particularly useful for framework development, where you need to guarantee instrumentation behavior without assuming specific backend configurations.
The span processor empties itself by filling the exporter with silence.